Guys, in this video we are going to see how to solve a first order homogeneous differential equation. So first thing we have to do is we have to check whether this is a first order homogeneous differential equation. To prove that, what we have to do is we have to equate this one, like dy over dx should be equal to function of y over x. And let's see whether we can write this function after this equal sign in terms of y over x. And first one we have y. Now to convert this one into y over x, what we can do is 1 over x. But if we multiply numerator by 1 over x, we have to multiply denominator also by 1 over x. And if you multiply both by 1 over x, you will get this is going to be just y over x. And in the denominator, we are going to have x over x. And the next one is going to be square root of xy. And we know that if you put 1 over x inside of square root of x, that's going to become x square, because we know that if it's x outside, that's equal to x square inside of the square root, right? So that's the way we are doing right here. Now let's go ahead and simplify this one. So first we have y over x in top, and in the denominator we have 1 plus inside of the square root we have y over x. Now the function is in terms of y over x. We can write this one in terms of y over x. Therefore, this is definitely a first order homogeneous differential equation. Now we have proved this is a first order homogeneous differential equation. The next step is we have to equate this y over x values to v. So here what we are going to do is v is equal to y over x, right? And then we have to write everything in terms of v, right? And also we have to know that dy over dx should be equal to this one, and dy over dx is equal to x dv by dx plus v. Now we have to write everything in terms of v. Now let's go ahead and write that. So we know that dy over dx is equal to this one, so this is going to be x dv by dx plus v. And in the other side of the equation, we are going to have y over x, that is v, and 1 plus square root of v. So this is what we have right now. The next step is we have to separate v to the one side and x to the other side. Since this is separable, we can separate and integrate. Now let's go ahead and do that part. So this is going to be x dv by dx. If I move this v to the other side, this is going to be v over 1 plus, and square root of v can be written as v power half, right? And this v we brought to this side, that's going to be minus v. And if we take 1 plus v power half common denominator, this is going to become 1 plus v power half, and in the top we are going to have v minus 1 plus v, actually v times v power 1 plus v power half. And let's continue. Let's simplify this one. So this is going to be x dv by dx is equal to v minus v times 1, that's going to be v times 1 power half. So 1 plus 1 power half, actually 1 plus half. 1 is 2 by 2. 1 over 2 is going to be 3 by 2. And in the denominator we are going to have 1 plus v power half. Okay, I missed something right here. V times 1 is v, and the next one is minus v power 3 over 2, right? So v minus v is going to be 0, and this is the only thing that's going to remain. Let's continue this part right here. So this is going to be x dv by dx is equal to v minus v is 0, and in the top we are only going to have minus v power 3 by 2. In the denominator we are going to have 1 plus v power half. Now we have to separate the variables, like we have to bring all the v to the one side and x to the other side. It's always best if we have to keep this dv in the dv and dx in the numerator, so we can integrate easily, right? So this is going to be this one we can move this v to this side and x to this side. That's way we can keep this dv and dx on the numerator. So first, if we bring this one to this side, that's going to be 1 plus v power half on top, and in the denominator we are going to have minus v power 3 by 2, and dv remains right here. And if we move x to the other side, this is going to be 1 over x, and dx is going to be in the numerator, so this is going to be dx. Now we have to do the integration, but before we integrate, we can simplify this one furthermore. Like if we write this one as two different parts, like 1 over minus v power 3 by 2, that can be minus v power minus 3 by 2, right? And the next one is going to be minus v power half over v power 3 by 2. If we bring that one to the top, that's going to be minus 3 by 2. So 1 over 2 minus 3 over 2 is going to be minus 2 over 2. So minus 2 over 2 means minus 1. So that's going to be basically 1 over v, right? So minus v power minus 1 is going to be 1 over v. And that's times dv. And in the other side we have 1 over x dx. Now all we have to do is do the integration both sides. So this is going to be, we have to add 1 more to the power and divide by that power. And this is going to be, if we add 1 more to the power, that's going to be minus v power. If we add 1, that's going to be plus 2 by 2. That's going to be minus 1 over 2. And also divide by minus half. And then the other side we are going to have ln v, right? And then in the other side of the equation we are going to have ln x. Now this minus minus cancels each other, and we can bring this 2 to the top. So this is going to be 2, and this is v power negative half, and minus. So let's continue this one right here. We don't have enough space. Let's continue this one right here. So I erase this part, and I'm going to write this continuous here. So this is going to be v power, actually 2 v power negative half, right? 2 v power negative half minus ln v. And in the other side of the equation we have ln x. Also we have to put a constant, because both sides we get a constant, and if we combine them together, we can combine them together and write it as one constant. So this is going to be a constant right here. And other side of the equation we have ln x plus constant. And let's now the final thing is we have to write everything in terms of y and x, because initially we had this equation in terms of y and x, so we had to replace everything back. And we know that v is equal to y over x, so we can write this one right here. And this is going to be, we know that minus half means 1 over square root of v, and we know that v is equal to y over x, but if it's, we can write this one as x over y. If we write, so to illustrate this one, what we can do is we can put 1 over, so we know that this is going to be y 1 over square root of x, y over x. This is same as 2 square root of x over y, right? X over y. And here we are going to have ln v is going to be equal to y over x. And in the other side of the equation we just keep this one as x plus constant. Now it's better to expand this one, because you will see that 2 square root of x over y, and this is going to be, when we divide we subtract, so this is going to be ln y minus ln x, right? Minus ln x. And in the other side of the equation we have ln x plus constant. So if you notice here we have minus minus, that's going to be plus, and if we move this to the other side, that's going to be minus again. So from this one we can see that we can cancel these two. That's why it's better to separate this one. Like we can write this one as ln y minus ln x. Now we have simplified this one, and that's it. Our final answer is going to be c is equal to, this one is equal to c, 2 square root of x over y minus ln y is equal to c, and that's going to be the general solution of this differential equation. I hope you guys find this video helpful. See you next time.